This is lesson 9.2, translations. Number 1, copy the figure and the given translation vector, then draw the translation of the figure along the translation vector. So the process for this is to start by drawing a line through each vertex parallel to the given vector. And then from here, we would measure the vector, and then along each parallel line, we're going to mark off that same distance going in the direction of the vector. So the vector is this long, then I want to mark off using a ruler, measure this distance, and then transfer that distance, same distance, mark off that distance here. And likewise for D, to measure this distance and copy that distance here. And that same distance and measure here. And then connect your vertices. So this would be the image translated to this vector. So we want to translate along this vector. So to the left, we're sliding it to the left. So once again, we would take our ruler and draw lines parallel to the vector through each vertex. After we've done that, we would measure our vector and then mark off that same distance along each line. And I'm just eyeballing it here, but once again, measure this distance, and whatever this distance is, let's say it is 1 inch, then we want to measure a distance of 1 inch from here, and then mark that off for point Z prime. Likewise for W prime and for X prime. Connect your vertices. For number 5, graph each figure and its image along the given vector. Triangle DFG with a vector of 5, -2. So first we would plot our pre-image. D is -8, 8. And F is -10, 4. And G is -7, 6. Then I'm going to translate it based off of this vector to the right 5 and down 2. So F, go to the right 5, and down 2. And that will be F prime. And same for G and D. And then connect your vertices. The object of the video game shown is to manipulate the colored tiles left or right as they fall from the top of the screen to completely fill each row without leaving empty spaces. If the starting position of the tile piece at the top of the screen is XY, use function notation to describe the translation that will fill the indicated row. So we want to move this piece so that it is right here. So in order to get there, function notation, we start off with where we begin, x, y, and then this arrow means that it will map onto, and then we want to denote how many to the right or the left for x, and then how many to the right or left for y. So for x, we would have to go to the right 1, 2, 3 to end up here. So that would be a +3. And for y, we would need to go down 1, 2, 3, 4, 5 spaces to end up so that this peg is right in here. So to go down, that is minus and then 5. For number 9, copy the figure in the given translation vector, then draw the translation of the figure along the translation vector. So using a ruler, you would make lines parallel to this vector through each vertex. And I'm having technical difficulties here. I'll be right back. So as I was saying, we would draw lines parallel through each vertex to the vector, and then in the same direction of the vector we want to mark off distances that are equal to the length of this vector, so measure the length of this vector, and then from each point, so let's say that this is 1 inch, then we want to go 1 inch along this line for A, and the same for B. Then measure from here 1 inch for C, or whatever that length is. And then connect your vertices. Same with number 11. Draw parallel lines through each vertex. Measure your vector. Mark off distances equal to that on each line. And connect your vertices. And for 13, draw lines through each vertex parallel to the vector. measure the length of the vector from each vertex in the same direction of the vector, mark off that same distance. And then connect your vertices. For number 15, graph each figure and its image along the given vector. Number 15, triangle MNP along the vector -2, 5. Which means that we're just going to translate our image to the left 2 and up 5. So first, plot your pre-image. M is 4, -5. N is 5, -8. P is 8, -6. Connect your vertices. And then from each point, we're going to, from our vector here, we're going to shift to the left 2 and then up 5. And connect your vertices for your image. For number 17, we have quadrilateral FGHJ, and we are translating with the vector of -5, -2. So left 5 and down 2. So our pre-image points are F, -4, -2. G, -1, -1. H, 0, -4. And J, -3, -6. So connect your vertices for your pre-image. And then from each vertex, based off of this vector, we want to shift to the left 5 and then down 2. So J prime would be right about there. F prime would be right about here. G prime here. And H prime right there. Connect your vertices for your image. A wide receiver starts from his 15-yard line and on the right hash mark and runs a route that takes him 12 yards to the left and downfield for a gain of 17 yards. write a translation vector to describe the receiver's route. So the trick here is that we want to reverse everything here. We want to think in terms of the route that he is running, the direction that he's going. So if he is starting, I'm sorry, I misunderstood. Actually, we wouldn't have to reverse anything. We would just start on his 15-yard line on the right hash mark. So he would be right here, and he is running 12 yards to the left, and then downfield 17 yards. So he's going to move this direction and then up this way. So left and then downfield. So the left 12, and then that would be up 17. So our vector is left 12, up 17. For 23, I want to write the translation vector, and based off of the examples, it doesn't say from blue to green or green to blue, but based off of the examples, the blue is the pre-image and the green is the image. So I'm shifting to the right and down. So I would just pick a point in the pre-image and then find out how far to the right I would have to go. So that would be to the right 3, and then how far down I would have to go to get to the corresponding point in the image. So down 5. For 25, Dexter's family buys tickets every year for a concert. Last year they were in seats C3, C4, C5, and C6. This year they will be in seats D16, 17, 18, and 19. Write a translation in words and using vector notation that can be used to describe the change in their seating. So if the first person starts at C3 and that first person ends up at D16, then from 3 to 16, that's a change of 13 units to the right. And starting at C and then moving up to this row, so that's a change of up 1. So then in words, we would just say they move to the right 13 seats and back 1 row. So since our vector is going in this direction, we're going to the right 13, but up 1, even though they're moving back a seat.